Good day to you, students. I hope you guys are doing fine in your various homes. In our last class, we discussed calculations involving equilibrium constant, when the equilibrium concentrations are given and when they are not given. Today, we are still going to continue in that calculations involving equilibrium constant. And by the end of this lesson, I expect each and every one of us to be able to calculate the equilibrium concentrations. We are not calculating equilibrium constant today. We are calculating equilibrium concentrations of the reactant and the product of a chemical reaction. Now, to start with, in our previous class, we learned how to make use of the I table, where we said I represents initial concentration, C represents the change in concentration, while E represents the equilibrium concentration. But here, we want to look at how we make use of the Highest table to find the equilibrium concentration. Equilibrium concentration when equilibrium constant is given. In the previous ones, equilibrium constant was not given, but today we are looking at the one when equilibrium constant is given. Okay, let's look at this example. Example 1. At the initial stage of a reaction, 2.781 molar of hydrogen gas and 2.78 molar of bromine gas are present in a reaction vessel. That is the initial stage. Then find the equilibrium concentration. Find the equilibrium concentration of H2 and Br2 as well as HBr at 100 degrees Celsius if Kc, that's our equilibrium constant, is equal to 400. And the equation of the reaction is given as represented on the board. Okay? So we are going to bring about our Highest table. So this is our Highest table we have constructed here. And this initial for H2, this is the reactant, these are the reactants, while this one is the product. That's the product, this one is the reactant. So the initial concentration of H2 as indicated in the question, this is 2.781 molar of H2. That's 2.781. Then for Br2, 2.781. Then at the initial point, don't forget in our last class we said at the initial point, nothing will be produced at the product. So that is why we have this one to be 0. So that is the initial concentration at the product. Then what will now be the change in concentration? Don't forget, when we start a reaction, the product will be increasing while the reactant will be decreasing. So the product is increasing by letter Y. We don't know the amount, so we are representing that with letter Y. So from there, you can now see that. That is why we wrote plus Y. But the number of mole of this product, 2, must also be written at the back of this Y. That is plus 2Y. In this case as well, don't forget the reactant will be decreasing. So this one is decreasing by Y. This one is 1 mole. That's why we wrote 1Y. Then in the case of this, minus, this one is also minus, this is minus Y. But because we have 1 mole here, that is why we have minus 1Y. So the change in concentration will now be, for this one, 2.781 minus 1Y. That's what we have here. This one is also 2.781 minus 1Y. That's what we have here. Then this one is 0 plus 2Y. So if you look at the final answer for the equilibrium concentration E, this one will be 2.781. That is the answer you have here, will give you this. Then this one is also 2.781 minus Y. But here, 0 plus 2Y will give you 2Y. So from what we have here now, we can easily proceed in as much as they have given us in the question. They have given us the equilibrium concentration. That's the equilibrium constant rather. That's 400. So we just substitute that. You write the equilibrium constant expression of that reaction, that is product divided by the reactant. Don't forget to put the number of mole of the product. That's why we have HBr squared divided by H2 times Br2, that is their concentration. So since our Kc is 400 in the question, 400 equals to, what is our HBR from the highest table? Our HBR from the highest table is, there's 2y. So you put 2y under that is 2y. Then don't forget there's a square there. 2y squared divided by, our H2 is 2.781 minus y from the highest table. Then multiply by BR2, which is the same thing as 2.781 minus y. Then from here, since this one is carrying a square, and don't forget this one and this one, they are the same thing, that is square. So you now have 2y divided by 2.781 minus y. Everything is square. Then from here, you can now square both sides. I mean, you find the square root of both sides. So we now have square root of this equals to square root of 2y divided by 2 minus 781, excuse me, (2y) divided by 2.781 minus y, then everything square. So this square will cancel this square root. So what is the square root of 400? 20 equals to what you have left here. So from here, then we can now cross multiply. So if you cross multiply, we now have 2y equals to this, then you solve for y. 22y will now give you 5, then you divide both sides by 22, and your y will give you 2.528. Now, to now find the equilibrium concentration of H, so you now go back to your ice table. Since you said the equilibrium concentration of H2 is 2.781, and you have gotten your y to be equals to 2.528. So what you do is that you start to put y equals to, you put y equals to 2.528 in that equation you have in the highest table. So from here, for the one for H2, that is 2.781 minus y, then our y is this. So if you put y to be equals to this, it will give you, these are final answer there. For BR2, you put y equals to 2.528, as we have gotten that in the previous time. So this is our y, then our final answer will be this. Then for H2, don't forget H2 on the highest table is 2y. So that will be 2 times, our y is 2.528. Then you put y to be 2.528 and it will give you a final answer. So from this, we have been able to find the equilibrium concentration of all the constituents we have in that reaction, both the reactant and the product. And I believe with this short video, we have been able to learn few things about how to find the equilibrium concentrations of either the reactant or the product of a reaction. So when we get to the Google Classroom, we are still going to have more of these examples at the Google Classroom. And as you watch this, and I expect you at the Google Classroom, I pray that God bless you. Thank you.